Okay, we are now going to look at section 6.4, finding the trig functions of any angle. Now, so far, we have only focused on the first quadrant from 0 to 90. As we were going through the angles, the 30-60 angle, and the 30-60 and the 45-degree angle, we were only confining ourselves to the first quadrant. An angle in the first quadrant between 0 and 90 is called an acute angle. Sometimes it also goes under the name of reference angles. A reference angle. And we went through that, pretty well. And what we're now going to do is take a look at what happens to the angles as they go around to all the four quadrants. What happens in the second quadrant, what happens in the third quadrant, and what happens in the fourth quadrant. Okay, so let's take one quadrant at a time. In the first quadrant, we've kind of, looked at the angles. That was very nice. Now we're going to look at the angles in the second quadrant. And let's take a typical angle between 90 and 180. And let's just create an angle here. I don't know, what is this angle? Let's say this is 120 degrees. And we want to find out a little about a 120-degree angle. But in order to find out what we would like to investigate about any angle greater than 90 degrees is there's no triangle here. Like, how do we create a triangle for 120 degrees? Well, what we do is we try to, no matter where the angle may be, it may be in the second quadrant, in the third quadrant, in the fourth quadrant, could be anywhere. But we would always like to convert the angle to a first quadrant angle. The reference angle. A first quadrant angle. So the goal is always going to be, I'm going to write that as a goal right over here. The goal is always going to be to convert all angles, no matter where they may be, in what quadrants, and eventually we'll talk about negative angles, but we want to convert all angles to a first quadrant angle. So here we have a 120-degree angle. And what we're going to do is not consider this part of it, but say that if we complete the triangle here, this angle has the same terminal line as this angle. Can somebody tell us what angle this is right over here? Right over here. How much is that angle?
60.
Who said it?
Josh.
How'd you know that?
180 from 120.
Very good. This is a 60-degree angle. So to generalize, we can say that any second quadrant angle can be converted to a first quadrant angle by taking 180 and subtracting the angle. So if I were given a problem, find the sine of 120 degrees, what I would really be doing is I'd be finding the sine of a 60-degree angle. That's a big advantage because we know what the sine of a 60-degree angle is. The answer would be the square root of 3/2. So that's what we're going to try to do. We're always going to try to convert angles to first quadrant angles, better known as reference angles. Acute, they all have different names. You can call them a first quadrant angle, you could call it an acute angle, you could call it a reference angle, same thing. We're always going to try to convert the angle, and we always do this. This is what Josh did. He took 180 and subtracted 120 and got 60. Okay, that's what happens in the second quadrant. That's good. Now, let's take a look and see what happens in the third quadrant. So let me go down here. All right, so the angle is going to be over here, let's say. This is the initial line. The angle goes around here to the terminal line, and that angle is 225 degrees. Once again, we don't want that angle. We want this angle right in here. This is the angle. Not the angle formed by the angle and the vertical line. We're gonna use this angle right here. Now, can anybody tell us how much that angle is equal to? A little more difficult, right?
45.
How'd you get that, Sandus?
I just did 225 minus 180.
Very good. Good. So what Sandus said is that from here to here is 180. So 225 minus 180 gives you what's left over here, which is a 45-degree angle. Very good. So in general, in the third quadrant, you take the angle, whatever you're given, what do we call it up there? We called it theta. So let's call it the same thing. We don't want to. It's going to be theta minus 180 degrees. This is how you find an angle in the third quadrant. For example, if I said to you, hey, what is the tangent of 225 degrees? You would say, well, it's equal to the tangent of 225 degrees minus 180, which is equal to the tangent of 45 degrees, which is equal to 1, if you remember correctly. Okay, that's the third quadrant. So in the first quadrant, it's just whatever it happens to be. In the second quadrant, it's going to be 180 minus the angle that's given. And in the third quadrant, it's going to be the angle minus 180. Okay? And now let's look at the fourth quadrant. So here we go. 0, 90, 180, 270, 360. Should have done that here. This was 90. This was 180. Let's see, that would have been helpful. Okay, now this angle is all the way over here. The initial line is here. The angle goes all the way around and winds up in the fourth quadrant. This is the fourth quadrant over here. This is the third quadrant. This is the second quadrant. This is the first quadrant. And this angle is, let's say, equal to 330 30 degrees. All right, well, if this angle is equal to 330 degrees, we're going to actually use this angle as the reference angle. We're going to use that angle as the reference angle. How much is that angle?
30.
Sandas, you have to leave something for the rest of the group. But it's too late. How'd you get, well, let's ask somebody else. So you gave us the answer of 30, and I'm throwing it back to the class now. How did Sandas get the answer of 30 degrees here? Josh, well, not Josh. Wait a minute. It's got to be somebody besides Josh and Sandas. There's like a lot of people here today. There's 19 people. Somebody else answer the question. How did Sandas get 30 for this angle, the 330? How did she convert 330 into 30? It's anybody except those two people. Talia, good.
360 minus 330.
Excellent. 360 minus 330. In other words, in general, it's going to be 360 minus the angle. And that will give us the reference angle. So let's summarize the whole thing. In the first quadrant, it's just whatever it happens to be. In the second quadrant, it's 180 minus the angle. In the third quadrant, where is third quadrant, it's the angle minus 180, and in the fourth quadrant, it's 360 minus the angle. For example, let's take an example. For example, the cosine of 330 degrees is the same thing as the cosine of 30 degrees, which is equal to the square root of 3 over 2. From the chart, remember the chart before? Well, the cosine of 30 degrees was the square root of 3 over 2. So we come to the conclusion that the cosine of 330 degrees is the square root of 3 over 2. And those are the four quadrants. That's how we convert angles into a first quadrant angle, a reference angle. Now, there's another consideration. It's not only a question of converting the angle into a first quadrant angle, it's also important that we know whether it's positive, whether the value is going to be either positive or negative. So let's go back to the first quadrant. You take an angle. The y is positive. You know, this value from here to here is positive because the value of y is always positive above the x-axis. This is positive. So therefore, all the functions are going to be positive. So all the 6 functions are going to be positive. In the second quadrant, well, the y part is going to be positive, but the x part is going to be negative. So let's see, tangent, which is opposite over adjacent, will be negative. Positive over negative is going to be negative. The hypotenuse is always positive. So because, you square it and all that. So the sine is opposite over hypotenuse. That's going to be positive. Cosine is adjacent over hypotenuse. That's negative over positive. So the only thing that's positive in the second quadrant is sine. And of course, cosecant. So it's also the reciprocal functions. So in the first quadrant, they're all positive. In the second quadrant, only the sine is positive. In the third quadrant, here's the third quadrant. So the sine is opposite over hypotenuse. That's negative over positive, is going to be negative. The cosine is adjacent over hypotenuse. Therefore, that's going to be negative. The tangent, though, is opposite over adjacent. That's going to be positive. So the tangent is positive in the fourth quadrant, and in the third quadrant. And in the fourth quadrant, I'll just tell you that the cosine is the only one that's positive. Okay, so we sort of derived all of this, and what I'd like to do now is just erase all of this and put it in one chart, because it's kind of confusing putting it in 4 different charts. So let's just summarize everything into one chart. So this is what I mean by one chart. Here are the 4 quadrants. 1, 2, 3, 4. So in the first quadrant, all the angles are positive. And whatever the reference angle is, it is. In the second quadrant, only the sine is positive, and of course also the cosecant. And the way you find the angle, remember, is 180 minus the angle. That's how you convert it to a reference angle, and this is going to be positive. The sine is going to be positive. Only the sine is positive. In the third quadrant, remember, it was the angle minus 180, and only the tangent was positive. And in the fourth quadrant, it was 360 minus the angle. So this is how you find the angle. And only the cosine is positive. This is all you need. So just reviewing. 0, 90, 180, 270, 360. In the first quadrant, whatever the angle is, that's what you find the value of the angle, because all the angles are going to be acute angles, first quadrant angles. In the second quadrant, whatever angle you get, it's going to be 180 minus the angle, and only the sine is positive. In the third quadrant, it's the angle minus 180, and only the tangent is positive. In the fourth quadrant, it's 360 minus the angle, and only the cosine is positive. Okay, so that's one chart that you need to know very badly. And the other thing you need to know very badly is this one from earlier. This was sine, cosine, and tangent. $30, $60, and $45. The sine of 30, remember, the cosine of 60. So I'm not doing it simply the way I remember it, but this is how you should remember it. The sine of 30, the cosine of 60, 1/2. The cosine of 30 is the square root of 3/2, and the sine of 60 is the square root of 3/2. And these will both be the square root of 2/2. Remember this from earlier. The tangent of 30, remember, was the square root of 3/3. The tangent of 60 was the square root of 3. And the tangent of 45 is everybody's favorite angle because it's equal to 1. This is what you need to know. This is what, during today's lesson, this is what we learned. And this is going to help us to do some very, very important things that are going to come up right now. Okay? So the first thing I want to ask you to do is find the following values. and I'm going to do a few just to get you into the mode of thinking and understanding of how to do these problems. So for example, the cosine of 150 degrees. The first thing you need to do is draw this. So you draw the four quadrants, 0, 90, 180, 270, 360. Okay, so this is what we're looking for. We want to find the cosine of 150. So the first thing we do is draw it. That's a 150-degree angle. How do you change an angle in the second quadrant? Here it is. It's 180 minus the angle. So this is equal to the cosine of 180 minus 150. Right? Once you identify that it's a second quadrant angle, using the chart up here, it's going to be 180 minus the angle. 180 minus 150 is 30 degrees. But we also need to know if it's going to be positive or negative. So look at it. It's a second quadrant angle, but only the sine is positive. Therefore, the cosine is going to be negative. Whatever that cosine of 30 turns out to be, it's going to be negative because the cosine is negative in the second quadrant. And the reason it's negative is because only the sine is positive in the second quadrant. And what's the cosine of 30 degrees? Cosine 30 degrees, square root of 3 over 2. Answer is negative, the square root of 3 over 2. That's the answer to the question. That's exactly how you do it. You first draw it, you then convert it, you then determine whether it's positive or negative, and then you write the answer. So the answer is either that's sufficient, or you could say the cosine of 150 is negative the square root of 3 over 2. Another problem. Well, first, let's look at this. Okay, so diagram, convert to a reference angle, determine if it's positive or negative. Let's do another one. Let's do tangent of 315 degrees. Okay, so the first step, step one, is to draw the angle. The angle is right over here. So it's going to go 0, 90, 180, 270, 360. 315 degrees. Okay, so the first thing we want to do is convert the, okay, so we've drawn, yeah, if this were a question on a test, it would say, step one, sketch the angle. We've just done that. Now we want to figure out how many degrees is it what's the reference angle? So in other words, this will be the tangent of 360 degrees minus 315 degrees, and that will be the tangent of 45 degrees. And this, you could use your calculator if you'd like. 360 minus 315. You know, I happen to know it because I've been doing it. But tangent. Okay, so what we need, so we've sketched it, we've converted it to a reference angle. Now we need to know, is it positive or negative? Well, the only thing that's positive in the fourth quadrant is the cosine. Therefore, the tangent is going to be negative. And the answer to the question is, now you look here. the tangent of 45 degrees is equal to 1? The answer is -1. In other words, the tangent of 315 degrees is equal to -1. I hope you understand that. And again, to summarize, there are 3 steps involved. Step 1, sketch the graph. Step 2, convert it. Convert the angle to a reference angle. Step 3, determine whether it's positive or negative, and that's the answer. And you can make it look really nice by saying that the original problem, tangent of 315, is equal to -1. Let's just do more problems. That's the only way to do it. Okay, so let's do the sine of 315 degrees. I'm going to give you a chance to try it. This is the goal, to change this, to find the exact value. Step 1, draw it or sketch. I think the word that we use is sketch. So you sketch the angle of 315 degrees. The initial line, the terminal line, this is 315 degrees. Okay, so that's what it looks like. That's step 1. Step 2, convert to reference angle. Reference angle. Okay, so in the third, now let's go up here for that. Let's go back to the original chart up here. So in the third quadrant, it's going to be 360 minus the angle. Okay, so you go back here, it's going to be 360 minus 315, which is 45 degrees. So you now have the angle. So we're now talking about the sine of 45 degrees. And the third thing you're looking at is positive or negative. Well, in the fourth quadrant, up here, in the fourth quadrant, only the cosine is positive. The sine is negative in the fourth quadrant. Therefore, this is going to be negative the sine of 45 degrees. And you think of the chart. I'm sure you've written it on your paper, so I don't have to keep going back up. But the sine of 45 degrees is the square root of 2/2. The answer is that the sine of 315 degrees is equal to negative the square root of 2/2. And that's how you do the problem. Let's do it again. The sine of 315. Step 1, sketch the angle. All right, this is an important step because it tells us what quadrant it's located in. So this first step is very important to tell us exactly where this angle is going to be located. All right, well, there it is. It's going to be this angle, actually, which is 45 degrees. Then convert to a reference angle. If you didn't already do it over here, it's going to be 360 minus 315 is 45. Put the 45 over there. So we're looking for the sine of 45 degrees, except we need to know, is the sine positive or negative in the fourth quadrant? Looking at the other chart, the one up here, we see that only the cosine is positive in the fourth quadrant. Therefore, the sine is going to be negative, and the answer is negative. And then, of course, you have to find the sine of 45, and you would look at this chart that we created much earlier. The sine of 45 degrees is the square root of 2 over 2, and there it is. And that's the complete problem. Here's another one. Find the exact value. This is how it's going to be written. Find the exact value of the tangent of 210 degrees. And I'll let you try that on your own. Step 1, sketch the angle. Okay, so draw the 4 quadrants. An angle, so this is 0, this is 90, this is 180, this is 270, this is 360. An angle of 210 degrees will be right about over here. This is where it is right here, 210. And step 2 is to convert to a reference angle. In the second quadrant, that will be, in the third quadrant, I'm sorry. In the third quadrant, that will be the angle minus 180. And that will be 30 degrees. Okay, so we now know, where it's located. We now know what the reference angle is. Now we need to know if it's positive or negative. So in other words, we're dealing with tangent in the third quadrant. Go back up to the, go back up here to this one, and you see the tangent is positive in the third quadrant. So therefore, this is, it's going to be positive, the tangent of whatever 30 degrees is. Well, where's 30 degrees? Go up to this chart. The tangent of 30 degrees is going to be the square root of 3 over 3. The exact value, remember. So the answer is the square root of 3 over 3. It'll be positive. So the conclusion we come to, the conclusion is that the tangent of 210 degrees is positive, the square root of 3 over 3. And that's how you do the problem. So once again, going through it again, sketch the angle, the 210 degree angle. It's in the third quadrant. In the third quadrant, we convert the angle to a reference angle by subtracting the angle minus 180. That's what I did here. The angle was 210. 210 minus 180 was 30. Then we needed to know if it was positive or negative. In the third quadrant, tangent is positive. So we know it's going to be positive, the tangent of 30. And then you go to the chart, which, you need to memorize that chart because we keep using it, or at least look back at it. And the answer is the square root of 3 over 3. And you're right, very nice and neat here by saying tangent 210 positive the square root of 3 over 3. Or you could actually just simply say the tangent of 210 is the square root of 3 over 3. You don't need the positive sign, because if it doesn't have a sign, you assume it's positive. So we have a lot of examples here. We have 1, 2, 3, 4. Let's do another one. Unless there's a question. Okay. So let's do the, what have we done so far? We did that, we did that. Oh, let's do, hey, well, let's hold off. Well, let's do it now. Let's do this one. Let's do the, let's not do that one. I was going to do one of the reciprocal functions, but I said, let's hold off on that for a while until people begin to feel more comfortable with this situation, okay? So let's do the cosine of 240 degrees. Find the exact value of the cosine of 240 degrees. Okay, let's begin. Step one, draw it. Where is it? 204, you do this. This is what sketching means. You kind of putting in all the different, oh, I should tell you what these are. I never did. When you get an angle that's right on the axes, these are called quadrantal angles. Quadrantal angles. The quadrantal angles are, 0, 180, 90. Let me put them in order at least. That would be helpful. 0, 90, 180, 270, and 360. These are called the quadrantal angles. Okay, so when you're actually sketching it, you should put in what the quadrantal angles are. And now 240, then it becomes easier to graph it, because here it's, this is, exactly where 240 degrees is located. It'll be right there in the third quadrant. Okay, so the next step is going to be to convert the angle in the third quadrant to a reference angle, which you do by subtracting 240 minus 180. And that's going to be equal to 60 degrees. So here we are. At this point, we know that the angle is going to be 60 degrees, the reference angle, but we need to know whether it's positive or negative. And in the third quadrant, only the tangent is positive, therefore the cosine is negative. The answer to this question will be negative the cosine of 60. And it turns out that the cosine of 60, if you look at the chart, is equal to negative 1/2. In other words, to sum up the entire situation, the cosine of 240 degrees is equal to negative 1/2. This is the answer to the question. So there's a lot to remember here. Sketching the graph is not so difficult, but you have to be able to convert it. And for that, just remember that it's 180 minus the angle minus 180, 360 minus the angle. And in terms of positive and negative, all of the functions are positive. Only the sine is positive. Only the tangent is positive. Only the cosine is positive. That's all you need to know. And that's how you convert angles between 0 and 360, that is. Does anybody have a question? We've done a lot of problems. 1, 2, 3, 4, 5, 6 different problems. And there's more in the homework, which I really suggest that you do over the weekend. Okay, if there are no questions, let's move on. I'm going to keep this chart up here, however. So this part is going to remain the same up here, because you could always I'll always be able to refer back to it. But the title of section number section 6.4 was finding the trigonometric function of any angle. That does not necessarily mean only an angle between 0 and 360. For example, and let me first ask you if it's possible, and if it is, what happens? Well, let's take an example. So here we are, and let me give you an angle first. So if the question were find the sine of the angle of 540 degrees. In other words, angles greater than 360. Fun, right? Well, don't panic. Think about it. Sketch it. What happens here? It's an angle of 540. So we already know that it's going to go like this, but that's only 360. How do we get the other 540? The first thing you do is take 540 and subtract 360. Oh, this is really not.
It gives you 180.
Yeah, I know. I don't want 540.
Yeah.
Yeah, I don't want 540. How about yeah, I don't want that. That's not going to work. How about
Try 560.
5, 6, you know something? No, I don't think we're ready for just any angle yet. Let's go with the angle of 570. Try 570. All right, 'cause that was going to come out to 180, which we don't want to get involved in that. So okay, 570. So 570 minus 360. Okay, so we went around to 360, we subtract that part of it, and we wind up with 0, 1, and 2. So we still have, when we hit 360, we still have 210 degrees left. So that's going to be right over here, right about over here. Okay, this is the angle of 570 degrees. So first you subtract the 360, you get 210. So this will become the angle of 500. The sine of 570 is really the same thing as the angle of 210 degrees, which is the same thing as the sine of 210 minus 180, which is equal to the sine of 30 degrees. There it is. So we started with 570. We subtract 360. We got 210. We then take care of a third quadrant angle, which is to subtract 180, and we wind up with the sine of 30. So that's what we're looking at now, a sine of 30. But remember that the terminal line winds up in the third quadrant where the sine is negative. The sine is negative in the third quadrant, and therefore the answer will be negative 1/2. That's the answer. So in other words, the sine of 570 degrees is negative 1/2. Let me ask you to do one. Let me ask you to do one. Find the tangent of 480 degrees. Okay. Let's draw it. 480, 0, 90, 180, 270, 360. So we start here and we go around once. Okay, so that's the 360 part. So 480 minus 360 leaves us with 120. So we still have to go into the second quadrant, and here's the angle right here. And that's the angle. It looks crazy. It looks sloppy and crazy when it's greater than 360. You can't help that, okay? So how do you convert an angle in the second quadrant? It's going to be 180 minus 120. We're really talking about a reference angle of 60 degrees. That's what you're trying to, that's the main thing. The main thing with getting this angle is not simply sketching it. That's okay. But what you want to do is you want to get it into a reference angle, an angle between 0 and 90. So you subtract 360, you get 120. It's in the second quadrant where you subtract the angle from 180. It's 180 minus x. 180 minus 120 is 60 degrees. So we're looking for the tangent of 60 degrees, but it's the second quadrant. Is the tangent positive or negative in the second quadrant? And the answer is, if you look at the chart up here, go back to the original chart. In the second quadrant, only the sign is positive, so the tangent is negative. And then, of course, you need to know what the tangent of 60 is. And I'm sure that you're looking at the chart, and that's going to be equal to negative the square root of 3. So the answer is that the tangent of 480 degrees is equal to negative the square root of 3. It's complicated. It really, really is complicated. I'm finding it complicated. And, I can understand why you would find it complicated. That's why we're trying to do so many problems. Let's do one more. Let's do one more of this type. So find the exact value of, let's say, 600 degrees. Whoops, I got to give you a function, don't I? Find the exact value of the cosine of 600 degrees. Okay, let's begin. All righty, so, we don't have to draw this. I think it's ludicrous to try to draw an angle of 600 degrees. Let's just convert it to a normal looking angle first. So let's take 600 degrees and subtract 360. Just picture that the terminal line goes around once to 360. We subtract that and we get 240. Okay, this we could draw because it's going to wind up in the third quadrant where this is 0, 90, 180, 270, 360. And here's the angle. The angle is 240 degrees. Okay, so in other words, it terminates in the third quadrant. This is what it tells us. And to figure out what the reference angle is, so now the reference angle will be 240 minus 180, which is 60. Okay, so we're talking about cosine. So the cosine of 600 degrees is equal to the cosine of 60 degrees. In the third quadrant, where the cosine is negative, the cosine is positive only in the fourth quadrant. So the cosine in the third quadrant is going to be negative, and the cosine of 60 degrees is negative a half. So the answer is the cosine of 600 degrees is equal to negative 1/2. And that's how you would do it. So we kind of streamlined the process. 600, you subtract 360 to get it to be, normal. And that's pretty normal. An angle of 240 degrees will wind up in the third quadrant. To get it to be a reference angle, it's going to be 240 minus 180. That's 60 degrees. So we're really talking about the cosine of 60, but since it's in the third quadrant, cosine is negative. So it's negative the cosine of 60 degrees, which is negative 1/2. That's how you do this problem. So we now can find the function of an angle between 0 and infinity, really, right? Because we can find any angle, even if it's larger than 360. We did 570, we did 480, we did 600, right? And the step here is to subtract 360, and then we revert back to the other method. And that's all it is right there. And now we need to do one more thing before we can, we have to do this, so let's do this. A question would be, if the topic, and the topic was indeed finding the trig function of any angle, have we covered everything? We could do angles between 0 and 360. We could do angles between 0 and infinity. What haven't we done yet? What haven't we done? Can anybody come up with the answer to that question? We've done every angle from, and it's not an open parentheses, I'll tell you that, right? It's going to be, this is what it is from 0 all the way up to infinity. That's going to be an open parentheses. What haven't we done? What haven't we done? Come on. What's left over? Is anybody there? Maybe nobody's in class. Holy cow.
Would it be the negative? Maybe I'll.
Yes, good. Yes, excellent. That's the spirit. I knew somebody would get it. Talia. Good. Very good. The negative. Can we have a negative angle? How do you have a negative angle? Does anybody have any idea how you would have a negative angle? Well, it's an academic exercise. So, what you do is you say, all right, well, if this is 0 to 90, to 180, to 270, to 360, what would the negative angles look like? Well, it would be 0 to negative 90, negative 180, negative 270, negative 360. In other words, the initial line is still going to be on the x-axis, but instead of going this way, I don't want to draw it because it's just going to confuse everybody. We're going to go in the opposite direction, like that. That's a negative. That's what a negative angle looks like. Let's take the sine of negative 150 degrees. Where is that? It's over here. This is negative 150 degrees. How do you do this? Okay, so Talia, that was a wonderful answer. Now, can somebody come up with how we would go about finding the sign of a negative angle?
Would you do negative 180 minus negative 150?
You're gonna get into weird stuff, right? Do you agree? You're gonna get into weird stuff. There's a much better way of doing this. Actually, not too difficult a way of doing it. You see, here's the terminal line. See this terminal line? This is called the terminal line. With the initial line, to create the angle, we go to the terminal line, right? This terminal line is the same terminal line as a positive angle going in the opposite direction where everything seems normal, right? Well, if this is negative 150, what's this angle that goes from there all the way to there? What's that angle going to be equal to? That's really the question. Think about it. The whole rotation is 360. I've gone negative 150. What's left?
210.
Who said it?
Josh.
Josh, you're like a shining star lately. It's such a beautiful thing to see. It really is. It really is. What you need to do is you need to subtract it from 360. Whether it's positive or negative, just subtract 360 minus 150. And we're really talking about a positive angle of 210 degrees. So if you have a negative angle, all you do is subtract the absolute value of that negative angle from 360. And that converts it to a positive angle. So can we generalize this and say that if you get a negative angle, if you get a negative angle, it's going to be 360 minus the absolute value of the negative angle? I mean, that's not, you'll never find that in a book, but I like that. The way you convert this to a positive angle is simply subtract the absolute value from 360. Whatever the angle is. When it was negative 150, we subtracted 360 minus 150, and you get 210. So there, and let's do 210. 210 is a third quadrant angle, so it's going to be 210 minus 180 is going to be 30. It's a third quadrant angle, so it'll be negative. What's the sign of 30? 1/2. This is the answer. The answer to the question is, what is the sign of negative 150? The answer is negative 1/2. Okay, let me give you a problem to try. The tangent of negative 210 degrees. Let's finish this off. So the first thing you do is subtract 360 minus 210. 360 minus 210 is 150 degrees. All right, so this is the angle that we're really talking about. In other words, the tangent of negative 210 is equal to the tangent of 150 degrees. Okay? And to convert it, so that's a second quadrant angle. So to convert it to a first quadrant angle or a reference angle, we subtract 180 minus 150. This is really the tangent of 30 degrees. Okay, so once again, it's 360 minus 210. Forget about the negative for a minute. It's going to be 360 minus 210 is 150. The tangent of 150 is the same thing as the tangent of 180 minus 150, or 30 degrees. And in the second quadrant, where 150 is, the tangent is negative. So this is going to be negative the tangent of 30 degrees. And the tangent of 30 degrees, if you look back at the original chart up here, right? The tangent of 30 degrees is the square root of 3 over 3. The answer is negative the square root of 3 over 3. So the answer is that the tangent of negative 210 degrees is negative the square root of 3 over 3. How do you like that? Where is it? There it is, right at the bottom here. So once again, convert it to a positive angle by subtracting the absolute values, so just 210 from 360 is 150. And then it's a second quadrant angle, 150. 180 minus 150 is 30. But a second quadrant angle, tangent is negative. There's the negative. And looking at the chart for the tangent of 30, that's going to be the square root of 3 over 3. And that's the answer to the question. Pretty neat. Now, I'd like to give you, there's a question in the homework that you may have trouble with. And to help you to do that problem that's in the homework, I would like to do one final question. Given the cosecant of theta is equal to negative 5. And theta terminates in the third quadrant. That's not how you spell third. T-H-I-D, third. Third quadrant. Find the sine of theta and the cosine of theta. I don't know. You want to try it? I'll ask the class. Do you want to try it, or you want me to just do it? We have a little time. We have about a half hour. Would you like me to just do it? You know, I'll do whatever you want at this point.
Yeah.
Yes, please.
Yes, do it right. Because we haven't really done a problem like this yet. We've been using 30-degree angles, you know, we've been doing angles, but this is a little different. Okay, so let me do this problem. So we're told that the angle terminates in the third quadrant. So this is what it looks like. This is theta. And we don't know any, you know, we don't know what the degrees are or anything. All we know is that theta, this this part of the problem is very important. And this is what it looks like. And the first question on the final would say, part A, sketch the angle. Well, there it is. It's a third quadrant angle. And you're supposed to do this actually, so I haven't really done it exactly the way it's supposed to be done. It's supposed to be like this. And you go into the third quadrant, right? Okay. And since cosecant is like sine, it's definitely going to be negative in the third quadrant. So we know a lot. We know it's the third quadrant angle. We know it's going to be negative. This is what we know. But we want to find the sine of theta, and we also want to find the cosine of theta. Well, it turns out, as you well know from 2 hours ago, that the cosecant is reciprocal function of sine. The cosecant of theta is -5, then the sine of theta will be -1/5. That's the reciprocal. And it's got to be negative. The negative makes sense now because it is a third quadrant angle. So far, is everybody okay with this? So this is what I know. I know it's a third quadrant angle, and it's going to be negative because it's cosecant, which is the same thing as sine, which makes sense because it does say -5. So we know the quadrant, and we know that the cosecant and the sine are reciprocal functions. Therefore, if this one is 5 or 5/1, then the sine will be 1/5. That makes sense. But the problem is, how do you find cosine? Because to find the cosine, we need to know more information than just the side opposite over the hypotenuse. So therefore, the next step is to draw a triangle. Theta is over there. The side opposite is 1. The hypotenuse is 5. Cosine, remember, is opposite over hypotenuse. So that's -1/5. And now we need to know what x is in order to figure out what the cosine is. So we use the Pythagorean theorem. X equals the square root of 24. We'll get to the simplifying it in a little while. Let's first get the cosine. So the cosine, so this side adjacent is the square root of 24. Therefore, the cosine of theta is going to be equal to the adjacent over the hypotenuse. Now, remember that theta terminates in the third quadrant, and cosine is negative in that quadrant. So the answer to this question, what is the cosine of theta? It's negative the square root of 24/5. I'd accept this answer. But you could, if you want, separate this into the square root of 4 times the square root of 6. -2 times the square root of 6/5. That's the simplification of it. And that's the answer to the question. So the answer to the question are two things. First, that the sine is equal to -1. Because here's the two questions. What is sine and what is cosine? Well, sine we got by simply doing the reciprocal. So that's one answer. And with the other answer, we had to work a little harder for. So the two answers are if this were a final exam, you want to present the answer in a very nice, acceptable way. The two answers are that the sine of theta, the sine of theta is -1/5, and the cosine of theta is -2 times the square root of 6/5. These are the answers. There's full credit. And there'll be one in the homework so this wasn't the actual problem on the final. The actual problem on the final is the one that I gave you in the homework.